All right, y'all. So now we are in our lesson of the day. So again, you should have notes, something to write with, pencil, paper, in order to take these notes. Again, pause the video as many times as you need. Rewind it until you are fully understanding what's happening in the example before you go on to your independent assignment. We are exploring symmetry within graphs of quadratic functions. A keyword that should already stick out with us is, of course, quadratic functions. But a word that we should know from childhood is symmetry. Symmetry. It's this word here, symmetry. Okay? It's also in a key vocabulary word that we learned previously, axis of symmetry. So here's our example problem. I am going to read it, model through it, and then there will be some questions at the end that I will answer as well. Then there will be another example problem where I would want you to work through that problem on your own, and hopefully this will give you a good help for your independent worksheet. So example R1, below you see only one side of a quadratic function. Complete the graph by plotting 3 additional points of the quadratic function. Explain how you found these points and fill in the table. So what we've been given is one side of a quadratic function. We have 3 points already identified for us on the line, and they're connected by a red line. Some things I already want to identify is that they told me that they gave me one side of my quadratic function. So that already lets me know that because it's a quadratic function, it's going to end up in the shape of a parabola. So it's either going to end up looking like a U shape or an upside down U shape. And as we can tell, ours is on the track of an upside down U shape, so we know we are definitely graphing a quadratic function. Now they want us to graph the other side of this function. That would imply that we understand one of our main vocabulary words of quadratic functions, and that is our axis of symmetry. Now, if this is one side of our quadratic function, and it looks as if our points are heading to have a high point, aka our maximum, that could possibly assume that our axis of symmetry is going to be right here, splitting our parabola straight down the middle in half. Now, think of something that is symmetrical. For example, this heart. That heart is symmetrical. If it's symmetrical and I were to draw a straight line down the middle, that means that this side has to be equivalent to that side, that they are equal on the same sides because of symmetry. Think about it, if we draw a line down our face, one side should be symmetrical to the other side. Well, that is going to be the same instance for our graph. One side of our quadratic function must mirror the other side of our quadratic function if this is technically a line of symmetry. So we're going to think of it as a mirror. First, I'm going to already plot the points that are already plotted on the graph. I'm going to put those in my table. All right, so let's think about things that are symmetrical. This point up here doesn't have another point on the other side, so I'm going to assume that that is going to be our highest point. Now, if I go to my second point, I want a point that is symmetrical to -1 and 2. Okay, this is my line of symmetry. My point is 1 point away from my line of symmetry, and it is at the y value of 2. So that means that on the opposite side, I need to be 1 point away, but at the y value of 2 to make it symmetrical. I'm going to follow the same pattern of symmetry to identify 2 more points. Here I have a point at -2 and 1. It is 2 values away from my line of symmetry. So that means I have to go 2 values away from my line of symmetry on the opposite side at the same y value of -1 and plot a point. We're going to follow that same tactic again. We have -3 and -6. My point is 3 values away from my line of symmetry. So I'm going to count 1, 2, 3 on the same y value because I want it to be symmetrical. And I'm going to plot my point here. And then we're going to connect this with a line. So we've completed this graph by plotting these 3 extra points. Explain how we found these points and then fill in our table. So how do we find these points? Well, we simply used our axis of symmetry and we mirrored we mirrored those values on the opposite side of that line of symmetry. So now we're going to put those values in our table. I want you to notice that 0 and 3 is our high point. It is our maximum, also our vertex, okay? It does not have a mirrored image because it is the highest point on the line. And there you have a completed parabola, a completed graph of a quadratic function, and its completed tables and its values. What you can notice in your table is that our y values, our f of x values, start repeating, and that is due to our symmetry, okay? Our x values might change, but our y values are going to be symmetrical. Our vertex, our maximum, our minimum is going to be that middle point within our table because our values are mirrored, okay? Now we have a few questions. What are the coordinates of the x-intercepts? What are the coordinates of the y-intercept? What are the coordinates of the vertex? Is the minimum or maximum? Is it a minimum or maximum? Now, we answered those questions a little bit previously, but anytime you're given a quadratic graph or a graph in general, I spy it, label it with the key features that you do know so that it can be helpful for you when you're answering the question. So it says, what are our x-intercepts? X-intercepts, if I go back to my definition in my vocabulary, those are when my line of my graph crosses the x-axis. So here I am going to my x-axis, and I have two x-intercepts. Okay, there are two. However, I don't know the exact coordinates of those points, so I'm going to approximate. I know they're definitely not close to 1 or negative 1. They're a little bit closer to 2, but not quite 2. So I'm going to say that this is 0, 1.8, and negative 1.80. Now watch how I wrote the exact values for those. Just for this instance, they're the exact same distance away from 0, so they'll have to be the same point. Then we have what is our, kind of different color, y-intercept. Y-intercept is where our line of our graph crosses the y-axis, and that is here. That point also does look like it represents another vocabulary word, and we'll get to that one in a second. Here it is crossing the y-axis, so this value is 0, 3. And then the coordinates of our vertex, well, that just so happens to also be our vertex. And it's also our maximum. Okay? And our vertex is written as an ordered pair. And it is also 0, 3. Because this is opened down, it has a high point, so this is a maximum. Alright, so now you have exemplar 2, given only one side of a quadratic graph. Determine the following key features. You're going to answer the same 4 questions. There's a fourth question added. X-intercept, y-intercept, or the coordinates of the vertex, and what would the sign of the leading coefficient be? So here we have our one side of our graph. There are 3 points plotted on the graph. What I want you to do is pause the video, try to sketch the rest of these points out on your paper, and answer questions A through D. Alright, so now that you've given that some thought and you've identified that other half of this graph and answered the 4 questions, you should have graphed, sketched something similar, identifying your x-intercept, y-intercept, vertex, and the leading coefficient. Alright, so we know that practice makes permanent, so make sure that you clearly understand what has happened in the last 2 examples for this video before you move on to the independent practice. You want to go back and understand the key features and how they are identified on the graph and how that axis of symmetry is helpful for us, because that is the main part of our objective for today. So what you want to do now is you want to go back to the classroom and you want to complete your independent worksheet. And here in your independent worksheet are multiple questions. You know, you can go back to any of the videos. The videos are on YouTube, so you have the opportunity to go back and rewind as necessary. Make sure that you also reach out for questions if you have those. Talk to y'all later.